In 1995, we just finished counting the whole population of the world. It was very exhausting.
Like really exhausting.
We counted 5.7 billion people.
And you know what? We have to do it again next year.
We have to do it again next year?
Yes.
And all the years.
All the years.
Oh, but
Don't
guess
be
what?
so exhausted.
But guess what?
What?
We can don't do that work and just make a formula.
Yes, we can do that.
Yes, a formula that exemplifies the population growth for each year, so we don't have to do it again.
That's really cool.
Yeah,
We
let's
should
do
do
it.
it.
Yes. Our problem says that the population of the world in 1995 was of 5.7 billion people, with a relative growth rate of 2% per year. With this information, we have to answer the following
We have
questions.
to find a function that models the population after t that represents years. We have to know by what year will the population double. We also want to know what will be the population in 2015. And finally, we have to sketch a graph of the world population in billions versus time.
First, we're going to explain the general procedure using this flowchart. First, we found out what was the function that represented the population growth rate. And it says that f, such as x, is equal to e elevated to 0.02 times t. And we have to multiply this by 5.7. In the next step of the flowchart, we have to find out when will the population double. To this, we're going to substitute y with 11.4, and we're going to isolate t. So here is our formula that says that 11.4 is equal to e elevated to 0.02 times t, all of this multiplied by 5.7.
The next step is to find the population of 2015. We were going to do this by isolating y and substituting t with the number 20. So we will have the following equation. F such as x equals 5.7 times e to the 0.02 times 20 power. Then we will graph the equation representing our problem by doing a stretching to get our graph to start in the coordinate 0.5.7. The x values corresponds to the years, in which 1995 represents our 0, and y corresponds to the population in billions.
Our final step is to make our conclusion. Biologists say that population can be represented using the exponential function formula. But what is the exponential formula? The exponential function says that f, such as x, is going to be equal to a, that is going to be our base. And we are going to elevate a to x. And a has to be a value that is going to be greater than 0 and different from 1. Now, we are going to represent our problem of population growth using the exponential function formula. Our base is going to be e, that's the natural base. The formula for population growth says that we have to write a coefficient of our initial population that in 1995, when the time was 0, was of 5.7 billion. So we're going to write 5. We're going to elevate our e to the value of x. X is going to be equal to the population growth rate, that is 2%. And we're going to express this 2% using decimals, that it's going to be equal to 0.02. we're going to multiply this growth rate by the time that has passed since our initial population, and we're going to represent this value as t.
Now we want to know when will the population double.
And the double is going to be 11.4. So we're going to substitute the value of y by 11.4. And we're going to isolate t. Now we're going to pass the constant terms to the other side of the equation. So we're going to pass 5.7 dividing. So we're going to have 11.4 divided by 5.7, and this is equal to 2. So now we have that e elevated to 0.02 times t is equal to 2. In order to isolate t, we're going to pass this exponential function to the logarithmic function. The logarithmic function of base e is equal to ln. That's a natural logarithmic. So the logarithmic function of 2 is equal to 0.02 times t. Why? Because we pass the x to the other side of the equation and we pass the 2 to the argument. Now we want to isolate t. So we're going to pass all the constant terms to the other side of the equation. And we're going to pass the 0.02 that was multiplying t divided. With the help of our calculator, we could know that the natural logarithmic of 2 divided by 0.02 is equal to 34.6573. So this is going to be equal to t. So we're going to add this 34.66 plus 1995, and we're going to have that in the year when the population will double is going to be in 2029.
We want to know as well, what will the population be in the year 2015? Considering we start calculating our population in the year 1995, we know that 2015 is 20 years away. So we will substitute our value t with 20 as in the following equation. That says y, which is the population, equals 5.7 times e raised to the 0.02 times 20. We will now solve this by doing the following. We will have to multiply 0.02 times 20, this being the relative growth and this being the year. We will get the result of 0.4, will be the power of e. After raising e to that power, and with the help of our calculator, we will get that the population in 2015 will be of 8.5034 billion people. After doing all these processes, we can now sketch a graph where we show how the population grows at the rate of 2% each year. 1995 will be represented as x equals 0, and the years after this year will be in the x-axis, and the population in billions will be in the y-axis. Knowing this, the graph will result as follows. Considering the function we use to represent the population growth since 1995, in which the population was of 5.7 billion people, with an increasing rate of 2%, we can answer the following. We were asked to find the function that models the population after t years. Considering that we should start from 5.7 billion people, we use the natural base and elevate it to the product of 0.02, which is the relative rate growth, times t, which is the year. Asked when will the population will reach the double. So we know that billion will be 11.4 billion. Using the exponential function here, that the population will reach double will be in. We were also asked what will be the population in 2015. Using the exponential equation, we can imply that if the population growth per year continues being of 2%, in the year of 2015,
2015, the population will be of 8.5034 billion.
Finally, the graph that models our population growth